to the next point.
Towards
We should ensure whatever we see is clear.
that means work is being done. We can see that it is in opposite direction. Good day, learners at home. My name is Hassan Buki. You are a regular physics teacher for senior secondary school on radio and television e-learning program of Ministry of Education, Kaduna State. Today, we shall be considering the topic crystal structure. On our outline, we have crystals, non-crystalline or amorphous substances. Then we have differences between crystalline and non-crystalline or amorphous substances. Then lastly, we have an assignment for you. Introduction, we have that there are two major classes of solids, which are the crystalline and the non-crystalline or amorphous solids. Now, the distinction between them, what differentiates between them is the arrangement of atoms or molecules in them. That is what differentiates between them. Now, the term crystal structure is generally used to describe the internal structure of solids. Now we look at crystals, and we say a crystal is a piece of solid matter in which the atoms, molecules, or ions are arranged in a highly regular repeating pattern or lattice. Now, crystals are small particles which make up a crystalline substance. Most substances do not exist as a single crystal. The particles in crystals are arranged in a regular three-dimensional pattern, which is called crystal lattice, which repeats over and over again in all directions. Now, this high degree of regular pattern arrangements of molecules is the principal thing or the main thing that differentiates solids from liquids and gases. Now we look at structure of simple crystals. Solid crystals consist of particles arranged in parallel planes. Crystals are built up from simple structural units called unit cells. A unit cell, which is also known as space lattice, is a simple structural unit made up of atoms, ions, or molecules from which crystals are built. Now, in a nutshell, we can say that a unit cell is the building block of crystals. Now we say there are 7 fundamental different kinds of unit cells. Namely, we have cubic, we have monoclinic, we have tetragonal, we have hexagonal, rhombic, triclinic, and rhombohedral. These unit cells differ in the relative lengths of their edges and the angles between the edges. Now, what differentiates between these unit cells, we said, is the length of their edges and then the angles between these edges. Each unit cell has 6 sides, and each side is a parallelogram, except in the case of a hexagonal system. Now we said each unit cell has 6 sides, and each side is a parallelogram, which means that there are 3 pairs of sides in a unit cell, except, just like we have said, except in the case of a hexagonal system. Now here we have the diagram of a unit cell. We have their edges, that's the length of their edges. We have A, B, and C. Then we have their angles. We have alpha, beta, and gamma. These are the angles between the edges. Now for this study, we will focus our study on cubic unit cells only. And we said in the cubic unit cells, all the sides have the same length and all the angles are the same. And that is 90 degrees. All the lengths are the same, all the angles are the same, and each angle is 90 degrees, which means that small a is equals to small b is equals to small c. And our angles alpha is equals to beta is equals to gamma and is equals to 90 degrees. Now there are 3 types of cubic unit cells. We have one, simple cubic. Second one, we have body-centered cubic, which is denoted using BCC for body-centered cubic. And then the third one, we have face-centered cubic, which is represented using FCC for face-centered cubic. Now, in the simple cubic unit cell, there are 8 component atoms or molecules or ions located at the corners of the cube. Example is the crystal of sodium chloride. Now here we have the diagram of a simple cubic crystal. Just like we have said that there are 8 molecules or atoms or ions and 1 at each corner. So we can see them here. 1, 2, 3, 4, 5, 6, 7, 8. Now we said in the body-centered cubic, that's BCC, in addition to the 8 components at the corners of the cube, it also contains an identical component at the center of the cube. So apart from those 8 components at the corners, there is one identical one also at the center of the cube. And an examples of such crystals are, we have chromium, iron, and platinum salts. Now here we have the diagram of body-centered cubic crystal. Just like we have said, here in the center, we can see an identical component with blue color at the center of the cube. And we have the other 8 components at the corners. So this represents a body-centered cubic crystal. Now we look at the face-centered cubic. And we say in the face-centered cubic, FCC, there are identical components at the center of each face in addition to those at the corners of the cube. Now, we said there are 6 faces in a cubic cell. So apart from those components at the corners, the 8 components at the corners, on each face, at the center of each face, there is also an identical component, which means that we have 6 additional components apart from those 8. And then that will give us a total component in a face-centered cubic to be 14. Examples of such crystals are those of common salts like copper, silver, aluminum, lead, etc. So here we have the diagram of face-centered cubic crystals. Now, just like we've said, on each face, we have this component with red color or rather at the center of each face, and these black ones are at the corners of the cube. And we have a total of 14 components. That's either molecules or atoms or ions in a face-centered cubic crystal. Now we look at non-crystalline or amorphous substances. And we say non-crystalline substances, they do not have the regular arrangement of atoms which is found in crystals. That is to say, they do not form crystals. They are said to be amorphous or without form. In many ways, amorphous substances are more like liquids than solids, and examples are glass and plastic. Now, substances that form amorphous solids, they usually consist of long chain, long chain-like molecules that are intertwined or twisted in the liquid state. They are intertwined or they are twisted in the liquid state. Amorphous substances behave in an odd manner when they are cooled. So we say that crystalline solids, they solidify at a constant temperature. Now here we have diagram of amorphous substances. We can see it is a chain-like molecules intertwined together, twisted together, like a thread of worms that are being twisted together. Here we have the graph, cooling curve for crystalline substances. We have temperature against time. Now, on the vertical axis, at that point, we could see that the substance starts cooling. At its melting point, which we now have the horizontal line, the solid crystals is being formed at that point. Then, from this point downward, the cooling continues until when it is completely solid. Then the next graph, we have heating curve for crystalline substances. Also we have temperature against time. Now from the beginning here to the melting point, we have solid. At the melting point, the temperature remains constant. And at that point, the solid changes to liquid. Then it now moves up to the boiling point as the temperature increases. So between the melting point and the boiling point, we have liquid. Then at the melting point, the liquid changes to gas. Here we have the cooling curve for amorphous substance, also temperature against time, and it is an exponential curve. This shows when after the heating is being removed, and we can see that supercooling with no crystalline formation. Next. So we say amorphous substances, they also soften, they become soft gradually when they are heated. Unlike crystal substance like ice cube, which will suddenly melt. It is for this reason that a glass tube can be heated in a flame and then it can be bent after heating to make it soft, then it can be bent. So here we have the differences between crystalline and amorphous substances. We have crystalline substances and then amorphous substances. Number one, crystalline substances have definite internal arrangement of particles, while on the other hand, the amorphous substances, they have haphazard distribution of particles. That means they have a disorderly distribution of particles. Number two, crystalline substances have cleavage plane along which they can fracture when they are struck. On the other hand, amorphous substances, they do not have a cleavage plane. Number three, crystalline substances melt sharply at a definite temperature when they are heated. That means they have a definite melting point. On the other hand, amorphous substances do not melt sharply at a definite temperature. They don't have a definite melting point. Number four, crystalline substances are regarded as true solids, while amorphous substances are regarded as supercooled liquids. 5, we say crystalline substances have long-range order of arrangement of particles, while amorphous substances, they have a short-range order of arrangement of particles. 6, crystalline substances are efflorescence substances, while amorphous substances are non-efflorescence substances. 7, crystalline substances usually show variation in physical properties in different directions, while amorphous substances do not usually show variation in physical properties in different directions. So students, with this, we end the lesson for today and for the topic crystal structure. But before I go, I will call on my colleague, Mr. Napoleon Kure, who will come and summarize the lesson and then give you assignment to do at home. Once again, I remain Hassan Buki. See you in our next lesson. Thank you.
Hi, learners. You have just listened to a lecture on crystal structure from my colleague, Buki Hassan. I'm Napoleon Kure. I'm here to summarize what he has just discussed with you on crystal structure. He started by, on the outline, trying to let us know the differences that exist, crystal structure, the differences that exist between crystalline and amorphous or crystalline substances. And what he has discussed so far, major things to take note of One, a crystal. Crystal structure. Crystalline substances. And then the differences between crystalline substances and non-crystalline or amorphous substances. He went on to let us know that there are basic cells which are building blocks of crystals. What he actually said about a crystal is a solid matter that is arranged by particles in a definite way. And those crystals, more of them, form what we call crystalline substance. And he went on to differentiate between a crystalline and non-crystalline substance by telling us some terms under there. And he went on to also let us know that the unit cell, known as a space lattice, are of fundamentally 7 of them. 1, the cubic unit cell. You have monoclinic unit cell, triclinic unit cell, tetragonal unit cell, hexagonal unit cell, a rhombohedral unit cell. And the discussion for today is based on cubic unit cell, which he further let us know that is made up of 3. 1, the simple cubic unit cell, the body-centered cubic unit cell, and the face-centered cubic unit cell. On the simple cubic unit cell, he helped us to know that the cubic, as you all know, a cube, all the sides are equal, all the angles internally are also equal. And at the corners of such a cell, there are what they refer to as component atoms, molecules, or ions. And if you look at the cubic, it's made up of 8 corners. So there are 8 atoms, molecules, or ions at those corners. An example of such is sodium chloride. On the body center, in addition to the simple cubic unit cell, there is an additional 1 atom, molecule, or ion at the center of the body to make up 9 of the component atoms, molecules, or ions. An example of such are chromium, and so on. On the face-centered cell, or cubic unit cell, in addition to the 8-corner atom of a simple cubic, a cubic has 6 faces, planes, or surfaces. At the center of each of the surface is a component atom. And if you add 6 to 8, it gives you 14. It's important as a student, in case you are asked to differentiate between these 3 basic cubic unit cells, in terms of the number of atoms contained, 1, in terms of the example of such substances, you should be able to tell. Very important. As I said, sodium chloride is an example of cubic unit cell. It's made up of 8 atoms at the corners, and there are angles between each side. Between the length and the height is alpha. Between the length, the breadth, and the height is beta, and gamma is between length and breadth. And each of them are equal. That you should know. And with this, as you go through what my colleague has discussed with you, you will have no problem. An assignment is here for you to be able to go through and keep yourself busy as you stay safe and keep learning. On the assignment number 1A, what is a unit cell? B, List the 7 different kinds of unit cells. Number 1C, how do the 3 cubic unit cells or crystals differ from one another? Number 2A, what is meant by crystal lattice? B, with the aid of a diagram, show the 3 cubic unit cells. With the help of diagrams, show the 3 cubic unit cells. Number 3, give the differences between crystalline and non-crystalline or amorphous substances. The differences. You were given about 7 of them. For any problem, you can contact us through this number, meant for just WhatsApp and text messages, SMS. Hassan Buki, 080 65 50 4346. I take it again. Hassan Buki, 080 65 50 4346. Napoleon Kure, 080 3636 2105. I take it again. Napoleon Kure, 080 3636 2105. Keep safe and keep learning. God bless you till we see in our next lesson. I remain Napoleon Kure. Happy day.